Okay, so we are starting Unit 2.3, Linear Functions. We're doing Day 1 and Day 2 today. So the first thing we're going to look at, and I want you to go ahead and write these down. The first question says, Miss Olson's grandpa is driving down Briarcrest and gets stopped by the cops because he was driving 80 miles per hour. I want you to look that 80 miles per hour is considered the rate of change. In this term, miles per hour, we have a change in distance over a change in time. We have done these kind of things before in change in y over change in x. So we have 80 miles per hour. So that is our rate of change. Make sure you write that down. On these next three examples, it says circle the rate of change in the following situations. Maria starts with $100 and spends $10 per week. We've got the pool man who charges $100 to look for leaks and $75 per hour to fix the pool. And Mike hikes 3 miles per day and he started with 12 miles. So the first thing we're going to look at is Maria. She starts with $100 and spends $10 per week. The rate of change, because we have dollars per time, week. That is our rate of change. The pool man charges $100 to look for leaks and $75 per hour. There's our rate of change to fix the pool. So I want you to go ahead and circle the one for Mike hiking 3 miles per day when he started with 12 miles. Okay? The next thing we're going to look at is the definition of rate of change. We can also find them from tables. You do not necessarily have to write all of this down. This is required. Rate of change equals the change in y over the change in x. So when we look at this, we have to see that just like before when we looked at our tables, we found the change or the difference in our y values over the difference in our x values. Okay, so let's look at the following table. Oh, before we do that, another way to write this, a word for change is called delta. It's a Greek letter. Stands for delta, so I would sometimes say delta y over delta x. That means the same thing, change in y over change in x. Okay, so we have in our table, we are increasing by 1, increasing by 1, increasing by 1. Here we're increasing by 6, by 6, by 6. And our change in y over change in x looks like our change in y for this particular change is 6 over change in x is 1, which is 6. If I looked over here, I'd have 6 over 1, which is also 6. So 6 is our rate of change. Now I want you to try. Find the rate of change of the following ordered pairs. Hint, make a table. Well, let's make a table. 3, 12, 4, 14. What is our change in y? Or plus 2, and our change in x is plus 1. So our change in y over change in x is 2 over 1, which reduces to 2. Okay? We're going to look at a formula how to do this later, but if we just jotted a table real quick, you'll see that a formula will be pretty evident soon. Here we have 2 points, and I do want you to sketch this graph. Negative 6, negative 3, 1, 2, 3, 4, 5, 6, negative 3, and negative 6, negative 5. 1, 2, 3, 4, 5. If we looked, we see that this is not possible for us to travel from one point to another. Like if this was a road, we couldn't drive on it. So again, if we made a table, oh, that was positive 5. I guess the 2 points were here. There's my mistake for the day. Okay. We don't have a change in x. It's 0. So we have 0 over plus 8. 0 over a number is 0. The rate of change is 0. There is no change in x. Okay? So I want you to try this one. Negative 6, 2, and 4, 2. I want you to set the table up and tell me if there's a rate of change in x and y, and if not, what there is. So go ahead and try, and we'll talk about it. You can even, I'm going to show you this. It says when finding rate of change, we usually refer to it as the slope. This is important. Rate of change is slope. What can it look like? Well, we can be increasing as we travel from left to right. This has a positive slope. I want you to draw this example and write positive slope. We are decreasing, so we have a negative slope. Here is our flat line. This is called a zero slope, or it's a horizontal line. And here, this word says impossible. It's a vertical line. Because it's a road that would be impossible to drive on, it has an undefined slope. Okay? Oh, go back. Wow, I'm really making mistakes today. Hopefully you guys caught this. This is supposed to be the change in y over the change in x. So we have 8 over 0. That's not 0. This is undefined slope. There you go. Undefined slope. Change in y over the change in x. If you caught it, you're already ahead of the game. The other definition you should be familiar with is rise over run. Rise is our vertical change, which is what y does, and run is our horizontal. So let's find the slope. I'll just go ahead and show you how to do this one. What I like to do is I like to find 2 points that cross pretty on the grid. So there's one there, and there's one there, even say. So this point is 2, 125. I know it's hard to see. And this point is 6, 325. So if I turn that into a table, I have the change in y, which is 200, over the change in x, which is 4. 200 over 4 is 50. Goodness. And when we refer to the slope, we use the letter m. So it should be written as m equals 50. So that's kind of all we're going to talk about today. But this is the most important part of this little video, is this definition. We've got it equals the rate of change is the change in y over the change in x. It's delta y over delta x. And it equals m. So go ahead and clean that all up. I apologize for the mistakes. I hope you guys have a great weekend.